Okay, so I wanted to go over section 1.9 and 1.7 inequalities. They're found on page 74 and page 102 in your book. And we'll start slow and then we'll end with the calculator. So you probably already know how to solve an inequality, so you can stop and do the problem if you'd like, or just kind of watch me do it. What you want to do is I like to subtract the lower terms. I'm going to subtract 3x from both sides and get 11 is less than or equal to 3x plus 8. Then I'm going to subtract the 8 from both sides and get 3 is less than or equal to 3x. And I want to get x by itself, so I'm going to divide the right-hand inequality side by 3 and then divide the left-hand side by 3. And that gives me 1 is less than or equal to x, which is also the same as x is greater than or equal to 1. We want our answer to be in interval notation, so I'll graph that. So you can see x is greater than or equal to 1 means that 1 is included in the solution, and all the solutions that are greater than 1, which are to the right, are part of the solution. So in interval notation, you have a bracket because you're going to include 1 to infinity, with a parentheses because you can never include infinity. Okay, so the second one has several fractions, but they have a denominator of 5. You can treat inequalities like equations, which means that if I don't like that 5 down there, that denominator, I can multiply through by 5 and cancel that 5 in the denominator out. I just need to make sure that I multiply every term by 5. So there are 4 terms, so I'm going to put times 5 4 times. That 5 is really 5 over 1, so what I'm going to do is cancel the 5 in the numerator with this 5 in the denominator, and that leaves me with just 2x. Then 1 times 5 is 5. Then again, I can cancel the 5 in the denominator with the 5 in the numerator, and it leaves me with 1. And then a minus 2x times 5 is 10x. So now I have no fraction. I'm going to add 10x to both sides and get 12x plus 5 is less than or equal to 1. And then I'm going to subtract 5 from both sides, get 12x is less than or equal to negative 4. Now I want to get x by itself, so I'm going to divide out the 12 to get x by itself, and whatever I do to one side, do to the other. So the answer is not negative 3. The answer is x is less than or equal to negative 1/3. Okay, we want to make sure we put it in interval notation, so I'll graph the solution. Negative 1/3 would be included in the solution. All the numbers that are less than negative 1/3 are to the left of negative 1/3. So the solution is negative infinity to negative 1/3 with a bracket. Okay, so number 2, these are combined inequalities. That means that you have an expression in between two inequalities. There are 2 inequalities here combined into one. 1 is less than 3x plus 4, and 3x plus 4 is less than or equal to 16. A better way of saying this is that the expression 3x plus 4, that number is between 1 and 16. So notice that the less than here and the less than or equal to here are pointing in the same direction. That's always going to happen in a proper combined inequality because you want the expression in the middle to be between a lower number 1 and a bigger number 16. So it's always set up the same way. So you don't need to pull it apart. What we want to do is get x by itself by subtracting 4 from the expression, and then you'll subtract 4 from the 1 and also from the 16. That's going to leave you with negative 3 is less than 3x, which is less than or equal to 12. So you have a new combined inequality, and all you have to do now is divide by 3 And so you end up with negative 1 is less than x, which is less than 4. In other words, we're saying that there's some number x between negative 1 and 4. All the numbers between negative 1 and 4 would be solutions, in fact. So we want to put that in interval notation, combine inequality. We really don't need to graph it. We're saying in interval notation all the numbers between negative 1 and 4 are solutions. We get to include 4 because of the equal to. We do not include negative 1. Okay, so here's our second example. Notice again that we have less thans. They're pointing the same direction. Negative 3 is smaller than 1/2, so this is a combined inequality. You could get rid of that 1/2 by multiplying through by 2, but 1/2 isn't that hard to deal with, so I'm going to leave it. So I'm going to get x by itself by first subtracting 7 from both sides. So that gives me negative 10 is less than or equal to 3x, which is less than or equal to 1/2 minus 7, which is negative 6.5. Then I'm going to divide by 3. So we have negative 10/3 is less than or equal to x, which is less than or equal to, and we have a negative 6.5 divided by 3. And we don't want to leave a decimal in a fraction. That's not simplified enough. So there are a couple ways you can do it. Without a calculator, what I would do is negative 6.5 is negative 13 over 2. Divided by 3 is the same as multiplying by 1/3. So now I can do that in my head, and that's negative 13 over 6. Okay, so these are both reduced improper fractions. Negative 10 over 3 is negative 3 1/3. Negative 13 over 6 is negative 2 1/6. So you can see that the more negative number is to the left. You can leave it improper as long as it's reduced. So I'll write it in interval notation. Okay, so in number 3 we're going to learn how to solve a quadratic inequality. And it'd be nice if it was just as easy as solving a quadratic equation, but there's a couple of extra steps. It starts out exactly the same. So when you see number A, solve 3x squared minus 3x is less than 2x squared plus 4, notice that it is quadratic. It's not equal to, it's less than, but the first step is the same, and that is you have to move all the terms to the left-hand side and get this less than 0. You want 0 on the right side. So if I move the 2x squared over, that gives me x squared minus 3x is less than 4. And then if I move the 4 over, I get x squared minus 3x minus 4 is less than 0. So the first step is the same. The second step is also the same. This quadratic, x squared minus 3x minus 4, needs to be less than 0. But I want to figure out where it equals 0 for just a minute, so I'm going to do what I always do when I have a quadratic that can factor, and I'm going to factor it into x minus 4 times x plus 1. Okay, now I have x minus 4 times x plus 1 is less than 0, and I'm going to temporarily set these equal to 0 because I'm trying to find where the function changes sign. The function changes sign when it equals 0. Before it equals 0, it might be negative, and after it might be positive, or vice versa. So I call these, when I'm setting it equal to 0 and find out x is 4 and x is negative 1, I'll call these my critical points because that's where sign change occurs. Okay, so step 1 is to get the quadratic inequality less than 0, or to get the 0 on the right hand side. Step 2 would be to factor. And step 3 would be to set each factor equal to 0 and find the critical points. So what I do with the critical points next is I graph them on a number line. So I want negative 1 to the left and 4 to the right. And these are where, if I would have plug 4 in, I would get equals 0. If I would have plugged -1 in, I would get equals 0. But I don't want 0. I want this function, or this side of the equation, to be less than 0. So what I'm going to do is check these regions. So what I'll do is I'll pick a number in each region to check. And I want to check right where I have it in factored form. That's where I want to check. So I'm going to put -2 in. -2 minus 4 gives me a -6. So I'm just going to write a negative right here. Then I'm going to put -2 right here in x plus 1, and I get a -1. I don't really care that I got a -1. I'm just looking at signs. So when I put a -2 in, I get a negative times a negative, which is a positive, because negative times a negative is positive. So what that tells me is any number to the left of -1 is going to give me a positive value if I plug it into this function. So I'm going to move over to the region created by -1 and 4, and I have 0 that I can check. So I'm going to put 0 in my factored form. What's this? Okay, so if I put 0 in, I'm going to have 0 minus 4, which is a -4. I don't care that it's -4, just that it's negative. And I'll put 0 in and get 0 plus 1 and get a positive 1. So 0, when I put it in, I get a negative times a positive, and that gives me a negative. So any number between -1 and 4 gives me a negative value. Then I have to check 5. So if I put 5 in, 5 minus 4 is a positive 1, and 5 plus 1 is a positive 6. So any number that I put in on the right side of 4, I'll get a positive value. Okay. Now I have to look and see what I wanted. I want this to be less than 0, which is, I want negatives. So I can look at my region, and the only place where I have negative values is the region between -1 and 4. And it's less than, not equal to. Remember, these are points where it equals 0, so I cannot conclude -1 and 4. I'm only going to include the numbers that are between -1 and 4. So in interval notation, my final answer is all the values of x between -1 and 4. Okay, we'll try B now. So you want to look and see that you have a quadratic. 4x squared is quadratic. It's an inequality, and you have 8x. So step 1 would be to get your terms on the left-hand side and get 0 on the right-hand side. Now I put this one on here because this is an easy one to factor, although not to many students. I think it's easy because I don't have to do guess and check. I can factor it simply by looking and seeing that they have something in common. So I don't have a constant term. That means I don't have to factor it into two binomials. I can just see that they have a 4 in common and an x in common. So I can pull out that 4x. That's called my greatest common factor. If I divide out 4x from 4x squared, I'm left with x. If I divide 8x by 4x, I'm left with 2. So that's factored. And again, once I have it factored, I want critical points. So I said each factor, 4x is a factor, equal to 0, and x minus 2 equal to 0. And I get critical points of 0 and x equals 2. These are called my critical points. That's where the function is going to change signs if I were graphing this. Okay, so what I do with the critical points is I draw a number line with my critical points, and I create these regions. So these two critical points create 3 regions. And I want a test number in each region. So I'll let -1 be a test number, 1 another test number, and 3 be a test number. I'm going to put these test numbers into the factored form and see what I get. So if I put -1 into 4 times x, I get a -4. And if I put a negative 1 into minus x minus 2, I get negative 3. So I get a negative times a negative is a positive in this region. Then I'll put 1 in. So if I put 1 in, I get 4 times 1, which is a positive 4. And if I put 1 in here, I get 1 minus 2, I get a negative. So positive times a negative is a negative. And then if I try 3, 4 times 3 is 12, that's positive. And if I put 3 in, 3 minus 2 is positive 1, so that gives me a positive. So positive times a positive is a positive. Okay. Now what do I want? Well, I want this side to be greater than or equal to 0. That means I want positive values. So if I look here, there are 2 areas where there are positives. Not only that, it can equal 0 because it's greater than or equal to 0. So I'm going to include 0 and 2 in my solution because that's where they equal 0. I'm also going to include all the numbers to the left of 0 since they're going to give me positive values, and all the numbers to the right of 2 since they'll give me positive values. So the answer in interval notation would be, you're going to have a union. It would be from negative infinity to 0. We include 0 with a bracket, union, bracket 2 to infinity. So that's that final answer in interval notation. Okay, the last one I put in because it's already somewhat done for us. It's in factored form, and when I see that, I'm happy. I'm like, okay, the work's already been halfway done. So all I need, since it's in factored form and it's already less than or equal to 0, I just need critical points. So x equals negative 2, x equals 1, and x equals 3 would be my critical points. That's the place where it equals 0. And they would be included because it's less than or equal to. So then I can just draw a number line, and this time I'm going to have 1, 2, 3, 4 regions that I need to check. And I need a test point in each region. So negative 3 would be a good one, 0 would be a good one, 2 and 4 would be a good one. So what I'm going to do is put negative 3 in for x. Negative 3 plus 2 is a negative. Negative 3 minus 1 is negative 4. That's a negative. And negative 3 minus 3 is negative 6. That's also a negative. And a negative times a negative times a negative is a negative. So when I put negative 3 in, I get a negative value. Right, now I'll check the next region. So I'll put 0 in. 0 plus 2, that gives me a positive. 0 minus 1 gives me a negative. And 0 minus 3 gives me a negative. So positive times a negative is a positive. So now I'm going to try 2 to represent the regions between 1 and 3. So if I put 2 in, I get a positive. And 2 minus 1 gives me positive 1, so that's a positive. 2 minus 3 gives me negative. That's a negative, and a positive times a negative is a negative. Now try one more test number. So let's try 4. 4 plus 2 is a positive. 4 minus 1 is a positive. 4 minus 3 is a positive. Positive times positive is a positive. Times a positive is a positive. Notice how the signs seem to be changing back and forth. That's going to happen most of the time unless you have a double root, so you know you're on the right track when that happens. Okay, so now it's time to figure out which intervals make the solution true. So we want all the places where it's less than or equal to 0. That means it can equal 0, or we want values that are negative. So if we look here, negative 2 1 and 3 will equal 0, and then the region to the left of -2 is negative, and the region between 1 and 3 is negative. So if we write this in interval notation, it's going to be negative infinity to -2, bracket, union, bracket, 1 to 3, bracket. Okay, so number 4 would be the calculator active portion. And so A is an equation. X cubed minus 6x squared plus 9x equals the square root of x on the interval of 1 to 6. So when you have an equation and you want to use your calculator, what you want to do is you want to put I like to put the more complicated of the two sides of the equation in y1, and then put the less complicated in y2. It doesn't matter, but you're going to put one side of the equation in y1 and the other side in y2. And this says on the interval 1 to 6. Interval always means x-axis, so what we're saying is that the x-min in the window can be 1, and the x-max in the window can be 6. And since there's only 5 units between the two, you can count by 0.5 and get a nice looking graph. Okay, so on the 89, what you're going to do is you're going to hit the diamond key and then the F1 button. So diamond and then F1, and you're going to get enter y1 equals x caret 3 minus 6 x caret 2 plus 9x. Then you hit enter, and then y2 you're going to put in the second button and then the times button. That's where your square root is, and then you'll hit x. So it's going to look like y1 equals x cubed minus 6x squared plus 9x, and y2 is going to equal the square root of x. Okay, so now hit the diamond key and go to F2, that's your window. And you're going to type in what I have here. X min equals 1, X max equals 6, X scale equals 0.5. Your Y min, you can let it stay -10. Your Y max can be 10, and your Y scale will be 1. And now you hit diamond and F3. And now you can see, since you're only on the interval from 1 to 6, you should see this. And we want to know where these two sides of the equation equal each other, so they are found right here and right here. So you have to find both of them. So the way that you do that, we'll find the one on the left first, is you should be looking at the graph and you should see F5 on the screen, math. So you're going to hit the F5 button, and then you're going to go to number 5, intersection. And then it says first curve, so you're going to use your left arrow key, hold it down until you're to the area where your first intersection is. First curve, you can see you're on the curve, the one that switches concavity, so hit enter. And then it says second curve, and now you can see that you're on the second graph of the square root function, so you hit enter. And then for the 89, it says lower bound. Well, that just means to the left, go to the left of the intersection. So you just are going to go right here. That's left, hit enter. And then move over a little bit more and go to the right and hit enter where it says upper bound. And then wait, and it says intersection, and the ordered pair that I see is 2.18, 1.47. Now, because you're solving the equation, the answer is only the x-coordinate. It's not the y-coordinate. Okay, so now we're going to do that again. So again, you're going to do F5, and you're going to do number 5, and then you're going to first curve. So this time you want to go over to the area of the second intersection. First curve, hit enter. Second curve, hit enter. Then it says lower bound, so you want to go a little to the left of the second intersection, hit enter. And then a little upper bound means go a little to the right, and then hit enter. And this time your intersection says 3.72, 1.93. And again, since we're solving the equation, the answer is only the x-coordinate. Okay, so the solution to this equation is, this equation here is x equals 2.18 or 3.72. And you can check your work by putting in 2.18 into all the places you see x and see if it equals the square root of 2.18. And same thing for 3.72. Keep in mind that if you do check your answers, since we rounded to the hundredths place, you're going to be a little bit off. But I did just check it, and when I put 1.18 in on the left-hand side, I got 1.46583. When I took the square root of 2.18, I got 1.47648. That's some rounding error there, but that is good enough for me. Okay, so this last problem, question 4B, this is test level. It comes from page 105, number 75, and we're only going to do part C. It says an appliance manufacturer estimates that the profit Y in dollars generated by producing X cooktops per month is given by the equation Y equals 10x plus 0.5x squared minus 0.001x cubed minus 5,000, where x is between 0 and 450. For what range of values of x is the company's profit greater than 15,000? Write your answers in interval notation. Word problems, I always like to define my variable. So x is defined to be the number of cooktops produced per month. And Y is the profit in dollars, and I'm looking to see if it says in thousands or anything, and it doesn't. Okay, and we want to know for what range of values of X is the company's profit greater than 15,000. So what I'm going to do is write the inequality. Okay, so what you want to do is hit diamond Y equals, put your equations in, and then from that screen, go to diamond window and put in your X min and X max, and then from that screen, hit F2, scroll down, and you'll find zoom fit at A. So hit F2 and A and get zoom fit. And when you do that, you should come up with a graph that looks like this. At least mine looks like this. And this blue line is the Y equals 15,000 line. So we want to know on for what range of values is the company's profit greater than 15,000. So that starts right here and ends right here. So we're looking at this interval here. So that means we need to find the intersection of these 2 points. So remember what to do. You hit F5 and then 5 for intersection. and then it says first curve, you can hit enter, and second curve, and you hit enter. The lower bound means go a little to the left of the intersection, hit enter, then go to the right and hit enter. And this intersection here is 279.13. That's your X value. Notice your Y value is 15,000. Then we're going to find the intersection to the right, so you start over and you hit F5 and the number 5 for intersect. First curve, hit enter. Second curve, hit enter. Then you want to go to the right where it says lower bound, and you're going to stop around right here to the left of the second intersection, hit enter. At upper bound, you want to move to the right of the intersection and hit enter. And then it says intersection is 400. And these are X values. Okay, so the interval notation would be parentheses, because it says greater than 15,000, 279.13, comma, 400, parentheses. If we want to interpret this, since it's a word problem, we would say that between 278 and 400 cooktops need to be produced to make a profit greater than 15,000. I rounded up to, I don't know why I said 278. I meant to say 280. Okay, so let's fix that. 280, because if I only make 279 cooktops, then I'm less than 15,000. But if I round up to 280 cooktops, then I am making more than 15,000. So 280 and 400. So this is the interval notation, and that's what the answer is. I just went a little further to interpret, to show you what you would do with, if I asked you how you would round in that situation. Okay, that's it. So that's a test level problem. This problem is easy to graph if you remember this right here that I'm squaring in blue. Once you get your X-min and your X-max set up in the window, then Zoom Fit's always going to get you a nice looking graph. So remember, you can't, Zoom Fit won't work unless you put a nice X-min and X-max. And so look for hints in the problem for a realistic domain. If they don't give you the realistic domain, then you can think about the realistic domain and set up your X-min and your X-max and then do Zoom Fit.